This is the lesson for Chapter 4, Section 2, Extension, and we're looking at slopes of parallel and perpendicular lines. So let's take a look at the first one here. Here we're looking at parallel lines, and I know lines are parallel if the slopes are equal. So here it says lines in the same plane that do not intersect are called parallel lines. Non-vertical parallel lines have the same slope, and that's what we're looking for here, the same slope. So right here, this is the slope of the line, 1/2. And I see this is the slope of this line, 1/2. So I know these lines are parallel. So a few ways we can do it. We could look at the equation and we can check the slope of the line, looking at it crossing at this point here and definitely crossing here. I can see it goes up 1/2, where this one does as well, up 1/2. Or we could end up using the slope formula. We could find out what the slope of the line is by subtracting 2 points y values and those same points as x values. And that's what we're going to end up doing on this problem, because here it's tough to see whether these lines are parallel or not. They look like they all are. Now again, we could end up using the slope by drawing a slope triangle. I could go ahead and draw this line here. I go up 1, 2, 3, 4, and then over 1. So this blue line looks as though its slope is 4:1. I could find that slope by using the points. So I could take those 2 points, 2 minus -2 over, and then I'll start with this point here because I start with the 2, so I got to start with its corresponding x component. -3 take away -4. So when you do this, you got to add the opposite, and when you do that work, you end up with 4/1, the same answer I got by using the slope triangle. Well, for the red line, I'll do the same sort of method. So for the slope triangle, I have to start at this point. I go up 1, 2, 3, 4, 5, and then over 1. So that slope is 5:1 for the red line. And if I used its points, I would do 3 minus -2. So the 3 minus the -2 over 1 minus 0. So the x component and the x component of the other ordered pair. And you see when I add the opposite, that gives me 5/1, the same answer I got from the slope triangle. So far we see these are definitely not parallel, so let's take a look at the green line and see which one it's parallel to. So I'm drawing a line going up 1, 2, 3, 4 spaces and over 1. So the green line has a slope of 4:1. So if I was to use its components, its ordered pairs, in the slope formula, it would be 1 minus -3. So I did 1 minus -3 over 4 minus 3. 4 minus 3. So I add the opposite, and you can see how that's the same answer I got over here, 4:1. So we would say that the blue and green lines are parallel because their slopes are the same. So now let's take a look at perpendicular lines. And so perpendicular lines and their slope. Well, lines in the same plane that intersect at right angles are perpendicular. So when they talk about lines in the same plane, they just mean in this two-dimensional surface here. And we see that they're on that plane, and when they make a right angle like this, that means they're perpendicular. So non-vertical lines are perpendicular when their product of their slopes is -1. So what they're talking about is we have -2 times by 1/2. If I can multiply the two slopes together, and they make -1, that means they're perpendicular. So let's take a look at our lines. And one thing I want us to do before we look at that, so when we talk about a slope here is -2/1, it's the opposite reciprocal, opposite sign and reciprocal. Opposite sign and reciprocal slopes are perpendicular. And so if we look, and this is the symbol for perpendicular, just an upside down T, And so look at this negative 2 over 1. Well, the perpendicular slope is going to be 1 over 2 because they're opposite in sign. One's positive, one's negative, and they are reciprocals of one another. And when you do multiply them, their product is negative 1. So let's see what we can do to find out about these lines. We could find their slopes the same way we did the other ones. We could take a slope triangle and up to it and see what we get. So this one we have to go down 2 and over 1, 2, 3, 4, 5, 6. So for the blue line, this was down 2 and then over 6. So notice I put a negative sign in front of that 2 because I had to go down 2 spaces. So again, that was down, and that's caused it to be negative. So negative 1/3 is the slope for the blue line. And let's find out the green line, because the red line is definitely not perpendicular to it, so it's either going to be the blue and the green or the red and the green. So the green, when I look at this one, I'll start from this point. I have to go up 1, 2, 3, 4, 5, 6, 7, over 1, 2. So its slope is 7 over 2. So you can see how that does not reduce, and those are not perpendicular. Again, I can get these same numbers by using the slope formula. So let's go ahead and do that for each of them. So I could do 6 minus 4. So I took the 6 and the 4, subtracted those, and then negative 5, take away 1. And notice that gives me 2 over negative 6. And when I reduce that, I get 1 over negative 3. And that's the same thing as saying negative 1 over positive 3. So they mean the same exact thing. As long as there's one negative, they make a negative. For the green line, if I subtracted those y values, it would be 5 minus negative 2. So 5 minus negative 2 over 0 minus negative 2. 0 minus negative 2. And so when I do that, add the opposite, you end up with 7 over 2. So let's take a look at the red line. Oops. On that red line, we'll start with using the slope triangle. So I'll start right here, and I have to go down 2 spaces, and then I end up going over 1, 2, 3, 4, 5, 6, 7. So I had to go down 2, so that makes negative 2 over 7. So if I use the formula, it would be 0 minus negative 2. So I got those by doing the 0 for the y value, negative 2 for the other point's y value, and then over negative 5 take away 2. So negative 5 take away this 2 right here. So when I add the opposites, I end up with 2 over negative 7, which is the same as negative 2 over positive 7. They mean the same thing as long as they have one negative. So let's take a look at the green line slope and the red line slope. If you're able to multiply them and the product is negative 1, which we have, then they are perpendicular. And notice that 7 over 2 is perpendicular to negative 2 over 7 because the slopes are opposite in sign and reciprocal. So they're opposite and in sign and reciprocal of one another. So I'll add that extra part in there, make it sound a little better. So once we have that, we've pretty much got it. So you can do one of two things. You can either show how the product of the slopes are negative 1, or you could end up saying this. You could say that because the slopes are opposite sign and reciprocal of one another, they are perpendicular. All right, so that's what you'll end up seeing on tonight's homework. Good luck.